Okay, so now we are going to discuss our last lesson of the electricity unit, which is relationships in series and parallel circuits. Okay, so a quick reminder, in a series circuit, current can only flow if switch is closed. Okay, so remember a closed switch means there's no break in the circuit and the electrons can flow all the way around the circuit from the negative terminal of the energy source or the battery to the positive. If the path of the current is broken at any point, current stops flowing. So in a series circuit, there's only one path for electrons to flow. So if the circuit's broken anywhere, so if you have an open switch or a light bulb's not working, then the current is going to stop. There's going to be no flow of electrons or electricity. Okay, so examples of this would be an open switch, a bulb being blown, a bulb being unscrewed. Okay, so this slide is specific to series circuits. So the current in a series circuit remains the same throughout the circuit as the number of loads increases. So what this is saying, guys, that in a series circuit where there's only one path for electrons to flow, the current is going to remain the same or stay constant no matter the number of loads. So if you have one light bulb, or if you add a second light bulb, or a third load, say a clock, regardless of the number of loads added to the circuit, the current is going to remain constant or the same throughout the circuit. So that means that the total current, remember guys, I equals current, remind you that here. So total current, which would be at the energy source, is going to be equal to the current at load 1, is equal to the current at load 2, load 3. Okay, so where it says I1, guys, just want you to see that I1, and I'll make that yellow, is like the first load here. I2, okay, would be like the second load here. Okay, so this is saying that the total current at the energy source is going to be the same at all the loads regardless of the number of loads. So the current in a series circuit is constant. So let's just look at current here. At the energy source, which we know is at the battery here, the current is 6 amps. Okay, so if the current total is the same at all the loads, then that means if we were to get the current at load 1, the current for load 1 would be 6 amps. Okay, the current at load 2 would be 6 amps. Okay, so stays constant throughout the circuit. The potential difference, or the voltage, as the number of loads increases, the potential difference decreases. Okay, so in a series circuit, the potential difference changes based off of the number of loads. So we like to say that the potential difference, or the voltage, splits, okay, depending on the number of loads. Okay, so with this formula, you see V total, so total voltage at the energy source, so the battery, is equal to voltage at load 1 plus voltage at load 2 plus voltage at load 3. Okay, so the voltage splits between the number of loads. So in this case, if we look at voltage here, use a different color. Voltage at the energy source is 8, okay, so right here, 8 volts, okay? Voltage at the first load, so V1, is 2 volts. And we know that the voltage at all the loads combined is equal to the total voltage. So if at load 1 we have 2 volts and the total voltage is 8, so we have 2 and 8, then the voltage at load 2 must be 6 volts, okay? Because V total is equal to V1 plus V2. Okay, V1 is 2 plus 6 is going to give us 8. Okay, which we see is the total at the energy source. Okay. So current in a series circuit is constant no matter the number of loads. The total is equal to the current at all the loads. And the voltage splits depending on the number of loads. So load 1 plus voltage at load 1 plus voltage at load 2 plus voltage at load 3 is going to equal the total voltage at the energy source. Okay, so now we're going to look at parallel circuits. So in a parallel circuit, current passes through a separate circuit. Okay, so we know that in a parallel circuit, there is more than one path for the electrons to flow or for the electricity to flow. Okay, circuits at home are in parallel. Okay, so remember, this shows that the electrons can flow out the negative. They can come this way. They can go this way. Or they can go this way. Okay? So now let's look at the relationship in parallel circuits. So you'll notice that it's the opposite in parallel circuits. So current in a parallel circuit, as the number of loads increases, the current decreases. Okay, so now we have like this opposite here where total current is equal to current at load 1 plus current at load 2 plus current at load 3. Okay, so this is going to be current in a parallel circuit is split. Okay, so if current at the energy source is 7 amps and current at, I'll put a 1 here, current at load 1 is 2 amps, then in order to get current at load 2, okay, we know that the current at load 2 plus the current at load 1 is going to equal the total. So current at load 2 must be 5 amps. That was not a good 5. So must be 5 amps. Okay, because again, 5 plus 2, so 5 at load 2, 2 amps at load 1 is going to be equal to the total, which is 7 amps. Okay, so current in parallel circuits is split or combines to make the total. Potential difference in a parallel circuit remains the same throughout the circuit as the number of loads increases. So regardless of the number of loads, the voltage or potential difference is the same at every point in the circuit. So if we have V2 here, because this is load 2, light bulb 2, if the voltage at V2 is 3, and we know that the total voltage, so let's look down here at our equation, the total voltage is equal to voltage at load 1, 2, and 3. So it's the same across the circuit. So if V2, so voltage at load 2 is 3, then we know voltage at load 1 is 3, and voltage total at the energy source is also going to be 3. Okay, so I will put here constant. So potential difference is constant in parallel circuits. Okay, so now we're going to do a little bit of practice with this. So we need to remember everything that we just learned about the relationships. So I'm just going to write up top here. I'll try my best with being neat. In a series circuit, current is going to be constant. Voltage, or potential difference, splits, or the voltage at each load combines to make the total voltage at the energy source. And in a parallel circuit, current splits, where current at each load combines to the current at the energy source, the total, and voltage, or potential difference, is constant no matter the number of loads all throughout the circuit. So number one, we have to recognize that this first circuit here is a series circuit. So we're going to use our information in a series circuit about current and voltage to answer these questions. So the voltage at the battery, okay, is 10 volts. The voltage at load 1 is 5 volts. We need to figure out what the voltage at load 2 is. So V2 we need to figure out. So remember, in a series circuit, voltage splits. So if the total voltage is 10 at the battery, that means that the voltage at load 1 plus the voltage at load 2 equals the total voltage at the battery. So that means that the voltage at load 2 Sorry guys, my computer froze there for a second, so I'm just going to reiterate. So that means that the voltage at load 2 is going to be 5 volts. Okay, because 5 plus 5 equals 10, and we know that the voltage in a series circuit splits. So 5 goes in there as well. Now we're going to look at the current. We know that current in a series circuit remains constant. Okay, so series circuit, constant. So that means that if the current at the battery, so right here is 3 amps, the current at load 2 is 3 amps, then the current at load 1 must be 3 amps, okay, because it's constant. So this is going to be 3. Okay, let's do this next example here. So now we need to recognize that we have a parallel circuit here, more than one path for the electrons to flow. So in a parallel circuit, voltage is constant. So no matter where you are at load 1, 2, 3, or the battery, the voltage is always the same. So voltage at the battery, total voltage is 10. Voltage at the first load, so V1 is 10, which means that voltage at the second load, so V2, must be 10 volts. Okay, constant. Current in a parallel circuit, we know is splitting, okay, or shared between the loads. So the current at load 1 plus the current at load 2 is going to equal the total current. So if we have a total current of 3 amps at the battery and current of 1 amp at load 2, then we need to figure out the current at load 1. Okay, so the current of load 1 plus the current of load 2 equals the total current. So we need to figure out what plus 1 equals 3, and we know that that is 2. Okay, you can also do 3 subtract 1 to get 2. Okay, so this is showing you that I1 plus I2 equals I total. Okay, so I'm going to put 2 amps there. Okay, and you guys have some more practice of this in your booklet on pages 32 to 33, and that's the electricity unit.